So today's tutorial is on the Versus framework. Okay. So in a nutshell, Versus tries to help with the task of comparing digital data. That's really it. So given two or more digital objects, we try to establish a metric between them, a proximity, right? We use the term digital object because it's fairly generic. It could be a file. It could be an image in a file, an online resource. It doesn't matter. If it has bytes in it, that's what Versus is interested in, the byte inside the file. So this might sound arbitrary. Why would we be interested in such a thing? It sounds pretty specific, and it's really not that arbitrary. There is a lot of application, and I'm going to briefly touch upon three of them, maybe four. The first one is information loss, which was the original reason why Versus came to be. So the idea is that if you go through file format conversions, you might lose some information right during that chain. So we want to know how much was lost. So you compare the initial file to the file you end up with. This was done originally for Polyglot, which Kenton is going to talk about this Thursday. The other use case is content-based retrieval. So given a multimedia file, for example, an image, find the closest ones in a large collection, right? So you're looking at distances between your query file or your query digital object and all the digital objects in the collection, and then you pick the ones that are closest to you, right? Another one could be finding duplicates, right? So another one could be finding duplicates. So if you have large collections of files, you want to know if there are duplicates. Now, if the files are the same, then it's somewhat trivial. But if the formats are different, then you still want to find duplicates because they went through a conversion, then it's a little more challenging. Here's let's talk about the information retrieval use case that we kind of used originally that kind of pushed the information retrieval aspect in Versus. Was when we did our census work, and kind of it's a simple example, but you have these census forms, they have cells in there, there's text, right? And so what you do is you might write down a word, and then you want to compare that word to your collection of all the cells in all the forms, right? And so eventually, ideally, you want to identify the closest one, like in this case, like Illinois with Illinois, right? Now, you can see how if you have a very large collection that if you do a linear comparison, that this would take a very long time. Every time you have a query and you're going against billions of cells, then it'll take a long time. So that's when the kind of indexing aspect came in. And I'll say a little bit more about it, but that was kind of a second phase of development. The original development was about comparing two digital objects. And then, when applying it to these kind of use cases, we realized, well, we need to do more. We need to create these indices that make this kind of query a lot faster. So kind of an optimization. So one slide about the history. Most of the funding so far, if not all of it, has come from the National Archives and Records Administration, NARA. I believe we started in 2010. I just briefly looked at slides I had on my drive. It might have been 2009. I don't know if you guys remember, but it was a while back. And like I said, originally focused on pairwise comparison, and over the past 2 years, we started doing this indexing, kind of optimization. The current build, like the current version, we talk about 0.6. 0.6 is arbitrary. It could be 0.9, 0.1. We actually had a 0.1. But the reason why we're not a 1.0 yet is that it's usable, but it's still in flux. There's a lot of things that are changing. And as you will see, one of the biggest contributions of Versus is this API that formalizes comparison. And as you know, if you have an API and people are writing methods against it, then you want to be very careful when you say 1.0, because then they rely on the fact that it's 1.0, and therefore, right now, if you want to make changes, So that's why one of the reasons why we're kind of careful about calling it a 1.0, even though you can use it today. And also, for a long time, it was kind of exploratory work. We really didn't know how we were going to do this, what exactly we were going to try to research, or kind of let's try a thing. So there are two main components, and these are the components that we're going to look at today the most. There's a core, which is Java code. It's a set of Java interfaces, that API that you kind of implement when you want to add methods to the system. There is inside the core a multi-threaded execution engine, where basically you send jobs at it, and it builds them up and it dedicates thread as a thread pool, and it runs them so that ideally you scale up, right, based on the engine. There is a registry, so that you can ask the system what method you have available, and also you can register methods, so that if you add more methods, it's easy to make basically query the system and ask, what do you know about? The second component, it's a web service, and that's the one that, from a user perspective, is probably the most relevant one. So if you want to use the system, you're probably going to go through the web service. So if your typical HTTP API, RESTful web service, it wraps the core, meaning the service itself runs the core underneath, and it also provides a master-slave architecture, so that you can set up a bunch of slaves for the master for many reasons. I'm going to go over in a little bit. I'm not going to talk too much about the clients that we have built over the years, that we have tried. Some of them are, up to date. Some of them are kind of sitting there and haven't been touched in a while. But I wanted to kind of just quickly, briefly mention that over the years we have been building some clients. Some of them are wrap and use the core. So, for example, the command line interface, the usual command line that just runs local, an engine. And so when you're running it, you're running a local JVM, right? Same thing with the desktop. But we also have, over the years, we've been building some web interfaces for the end user to kind of explore and submit execution. And those use the service. I'm not going to show too much of these clients. I'm probably going to stick to the service and the core for the most part today. With the exception of maybe if we have time, I'll show some of the stuff that we're doing together with Medship. So why would I use Versus instead of writing specific implementation as need be? So this is the usual question that comes up. It's like you show a framework, and then they're like, okay, I have to go through all these kind of hoops to take my algorithm and put it inside this framework. But why can't I just run my algorithm independently, right? That's really one of the questions that always comes up. And the answers, they're the usual answers, but I think they're very important nonetheless. And that is because we really want to create a library of existing methods that people can reuse, right? And you'll see that we split up the flow of steps in well-known steps, and that is so that the methods that we're building are more self-contained, so you can mix and match between them. So the goal is, right, to build this library so that other people don't have to build everything from scratch. It's also to share methods with community, ideally, right? Somebody writes a method, then somebody else is interested in something like that, and if they know how to run it inside Versus and there's bindings for Versus, then they don't have to worry about anything else. Instead of having to know how to compile it, how to get input to it, and all of that stuff. It organizes coding clear components, and I'll show a little more about this in a second. And then there's this execution environment, service infrastructure, right? The idea that you don't have to worry about how to manage threads and all that stuff when you're running this large collection. You let the system build one, and then you can. Any questions so far? Pretty high level, but are there any confusions of what this is for? No. So this is a diagram of the API. This is the pairwise comparison API. It's pairwise, meaning you always start with two files. Go ahead, Edgar.
One of the questions that came is the program made, for example, are identical, or one is color, the other is black and white. I don't know how to use the algorithm. It's VersusTutorial identify them as the same.
Yeah, it's all about what measures you use, right? So that kind of information is encoded in the measure. So let me explain a little bit this diagram. This might help. So you start with your digital object. These are bytes, right? They're encoded in some format. So let's use images because everybody knows images, right? You might have JPEG, you might have PNG, right? You might have TIFF. But you know that in there, logically, right, there's a bunch of pixels. So what we do is the first big step is how we go from digital object to feature descriptor, okay? So a feature descriptor is a representation of the information inside the file, right? That's very generic in terminology, right? I mean, it could be anything. It could encode very little information or a lot of that information. So, for instance, it could drop the color and keep the grayscale, right, and have all the pixels. Or it could go over the image and keep things as just what colors appear in what numbers, and keep that histogram of colors, right? So a feature is just a representation of the original file. There is usually information lost. You lose information, but the reason why we do that is because you want to focus on one specific aspect of that original digital object, right? So how do you get there is we split that in two pieces. One is adapters and the other one is extractors. Adapters are simply a way of getting the raw information out of the file. So they're a way of extracting file format, for example, right? If you have JPEG, PNG, and TIFF, well, you just want the pixel, right? Ideally, an adapter helps you with that. So there should not be much information lost when an adapter gets information out. So for example, an adapter might implement an interface called as pixel, and that returns a double array, and where each number is, one of the pixels that represent that multi-dimensional array. The extractor itself acts on that pixels, very generic, higher level than the original encoding, and tries to extract a specific feature, right? We have a feature, right? We have some data structure in memory that represents some aspect of the original file. Then we have measures to establish some proximity between the two features, right? So we're not talking about the files, original files anymore. We're talking about those two feature descriptors. We call that a proximity. Proximity, it could be a similarity or dissimilarity. Usually it might be just a double, right? But the semantic of it are important, and you'll see one of the difficult things here is to actually be able to map these numbers across measures, because different measures might provide, right, different numbers on a different scale, right? Some might go from 0 to 1, some might be 0 is the same, 1 is not, and vice versa. So one of the big challenges for proximities and representing these numbers is how to then compare them to each other, because some of the use cases that we want to be able to support are run a bunch of different measures on the same files, right, and compare the results. Any questions? Yeah. Yeah. So measures are typed by feature. So measures accept features of a certain type. So yeah. So you might have measures that accept the same type of feature, right? And you might have measures that accept completely different. So, yeah. Think of it as you can match feature descriptor types to measure and vice versa. And so when thinking about the search space of all the possible comparison that you might want to do, either. Yeah.
To the point where the question appeared, you mind repeating?
Oh yeah, sorry. Yes.
Full set.
Yeah.
The question was, and then also, Constantino's asked if you could describe how versus
I will at the end. Yes. Yeah, I will at the end. Any other question? No? Are we good? Okay. So bear with me, one more slide in terms of kind of big picture stuff. So like I said, 2 years ago, we started saying, okay, if we're doing kind of information retrieval and we're doing linear comparisons between the query and every single object in the collection, that might get really slow. So really the one solution is to build a representation of the collection, right, that is faster to query, okay? So we start asking ourselves, right, how can we do that? How can we support that in Versus? And the design that we came, that we came up with was the following. And if you look up here, up to feature, this is the same pieces that we use in the pairwise. So again, going back to that reuse. So once you create an adapter and extractor, you can use it in both cases. The red stuff is kind of the new pieces. So there is every time, so there is an index error, I should say index error. But the idea is you take this digital object, they come in, and you extract a specific feature descriptor, and then you add that feature descriptor to an index, okay? And then whenever you like, you come in with a query object, usually, right, they're the same type. They have to be. The adapter and the extractor is the same one that runs on that query object. They create the feature of the same type, but now you're running a different function. You're running a query function on the index. Again, very high level, not much about the details, but I think the important thing here is that there is overlap between the two. Yeah. Okay. All right. So I have a few notes at this URL. If you could please all go to it. I'll leave it up for a little bit. We don't put requirements on how you implement it. Again, all of these are Java interfaces and classes that you implement. So if you want to talk to a relational database, you can. If you want to talk to something else, you can. You can build it or talk to external resources. Later on, I'll try to go over, well, we will go over what it takes to create one of these components so you get a better sense. But it's left fairly open. The only requirement is really that you're running Java. That's really the only requirement. Okay. Yes, sir.
The query object goes to the database. Why do you have adapter that
Index the query object?
Yes.
Hmm. Because your query might not, you might not want to store the query object in the data, in the index. Yeah, so in the case of census, it was that input image, right? Somebody writes something, and then that image is your query to the rest. Did I go back? No. So this diagram might be a little confusing, but think of this first row. This happens every time you want to add an object to your collection, which is your index. Okay. So let's say you have a million files. You go through each one of them, and they get added to the index. Okay. Now you come in and you say, I want to find something in this collection. So for example, if you have a database of faces, and now you look at me and you're like, who's this guy? You take a picture. That picture that you took of me is your query object, right? So that picture you took of me, you might not want to store inside the index. You just want to know, do you know about this person? If your query is the same, is already inside, yes. This assumes that your query is not by default. Yeah, yeah, yeah. No, that's a very good point. Yeah. Mhm. Yes. Okay. All right. Are we good? Okay. So let's go to this URL. I'll pull it up. I don't know if you can see it here. Maybe it's a little small. Let me go back to the slide. All right. That's the problem with 9 a.m. But only the speaker could be happy. The rest of the room. Pretty pain. Next time we should bring coffee for everyone. Are we good? Edgar, did you get the URL? Okay. All right. So please don't jump ahead and just start going down the list. I'll try to kind of drive you to it. But this is there, and if you want to go back to it, you can. And there we go. Okay, hopefully it's readable. Also, it's probably incomplete, so we'll add some more information over time. So you can check back. This is primarily a tutorial. It doesn't really tell you much about Versus. It just kind of does, okay, this is some of the things you can do if you want to try using it. So the requirements, they're fairly simple. You really just need the Java runtime environment to run a service if you want to just start the service. We have a service set up at this URL that we're going to try to hit today, all of us. Hopefully it doesn't fall over because it hasn't been tested very much. But the next step after working against this service will be that we'll all download a version of the service and we'll all run it on our machines. Okay. So, but we'll start by trying to run against this central service. So like I said, there's two main components, service and core. We'll start at the service level because that's kind of more the end user or the developer kind of primary concern initially. And then we'll look at the core in terms of how to extend that to the system. Okay, so this is a RESTful web service, so you can use whatever client you want to talk to it. I'll use curl. And probably I'll switch between curl and the CREST client inside Chrome. If you're on Mac and Linux, you should have curl. If you're on Windows, you can download a build. I've tested it yesterday, it worked pretty well. But if you're on Windows, you might want to try this extension for Chrome. I haven't listed extensions for Firefox and other browsers. There's plenty, so it should be fairly straightforward. The other thing that you can do is, if you're just reading information right now, you can actually go to it through the browser. So if you click on this link over here, you should be getting a list of endpoints. So this is the actual service that is talking to the browser. Glasses on. All right, so let's take a look. Let's browse around. Let's start with curl, because we mentioned curl. So the first thing that we're going to do is we're going to ask the system what extractors are available inside of it. We specify a header, which is application JSON. So we're asking for JSON ideally. If we don't and we leave this out, it's going to do a get against it. And by default, this particular endpoint returns JSON anyways. So I'll go ahead and copy this. Yep. And then I go to a terminal, which I hope I can make bigger. Is this big enough? Paste it in. I run it, and I get back a bunch of JSON, which is hard to read, but if you're a program, it's easy to parse. We go to the browser, and we go to the same URL. So we go to version 1 here, and we go to extractors. Version 1 API, version 1 extractors. We see a list of IDs. The IDs of all components in the system right now are Java, fully qualified Java class name. It's a class name right now, okay? So that's why they look long, and maybe they look scary. But the good thing is that you can use whatever class name you want, package you want to identify your organization, who you are, right, and so on. If we click on one of them, for example, RGB histogram descriptor, we get some basic information about it, which in the case of extractors is the name, which is a pretty name. So this does a pixels to RGB histogram, and a feature type. That is what feature this extractors create. So this is what feature the type of the output of the extractor. If we're talking about right here, this extractor output, a feature. So the yellow stuff is the one that for the most part we list. And it's the stuff that we decide, that we pick when we submit a comparison. Adapter extractors measure. Go back to the browser. Now there's a small, tiny bug in this web page. If you have a flash at the end of version 1, and then you click on it, it adds version 1.5. This is a tiny little bug that is easy to resolve, but just keep that in mind if things are breaking. So, here are our adapters. Here's a list. There are 4 of them. These are adapters currently deployed inside the server. I'll show you how to add and remove adapters later on. Look at extractors. Here's our list of our measures. Each one of them has different metadata. There's a bunch of other endpoints that we're not going to discuss for now, but let's go back to our tutorial. I can find it. All right. Oh, that's why. Okay. So what we did was list extractors. If we make this request, I'm not going to do it, but if you make this request, you're going to get back text HTML to highlight. Actually, let's do it. Just 1 click away, well, 2 clicks away, more or less. Here, text HTML. Here's the text HTML that the browser, right? 2 different return types. Okay, so let's make things a little more interesting, and this is where things start getting actually like compelling if you think about it, and also maybe the kind of hard to read, but I've listed the arguments for our post. So we're doing a post to the service, right? So we're creating information. Our post to the service is going to this URL. So we're posting to comparison. If we go in the browser to this particular endpoint, what we will see is that there is 2. These are the IDs of previous comparisons that were done. If I select this ID, I add it to the end of comparisons, then I get information about that specific comparison. We're going to submit our own, so you'll see, you'll create your own in a second. So when we do our post, so this is a basic post, it's like a form in the browser posting. Eventually we should support JSON as kind of the payload of the post. For now, this is your URL encoded form. So this is a very important piece of the curl request. This you can actually leave out because it defaults to post, but that's okay. So let's look at the payload of our submission. So what are we sending over? We're sending over 2 URLs. Okay, these are our two digital objects. Okay, the URL available on the web. There's an endpoint that allows you to upload the file and get a URL back if you have a file that is not available on the web, right? For now, for the for simplicity, and also because it's kind of a neat feature, in our tutorial we're going to be using URL. So I picked two URLs. You can pick different ones. Please don't pick huge files because it's going to take a while. But one is this NCSA logo. And the other one is our group logo. Okay. Then we specify an adapter, an extractor, and measure. If you remember diagram, those are the orange pieces, right? That's all they are. They're the types of the orange pieces. So what we're saying in this particular case is we want to use a bytes adapter. Okay, just take the raw bytes out of the file, nothing else, raw bytes. We're gonna create an MD5 signature of those bytes. And we're gonna do this distance measure, where the distance measure is actually really trivial. I think if they're 0, they're not the same. If they're 1, they're the same. This is for just a simple demo. We'll use more compelling methods afterwards. But these are the three this is the setup of our job. So go ahead, copy this particular curl, and run it. I'm going to, let's get the command line for that. Okay, so this is hard to read, but this was what was returned. This is the ID of the comparison. Because the comparison could take a very long time, you're given back an ID and you're told, go and check. I might be done, I might be not. But it's fire and forget, like any RESTful web service. If I go to comparisons and I list them, hey, look, everybody submitted something, or a lot of people submitted something. My specific one has this ID. Bam. Okay. So this is kind of hard to read. So what I'm going to do, I'm going to show you the simple kind of TREST in the browser in case you're using this for something similar. TREST client. I'm going to put that in so I have it formatted. Okay. And so this was my job. Status is the most important thing. It looks like it's done. It could have failed or it could be running. What came out is 0, which for this particular distance measure means they're not based on the MD5 checkpoint. I know, so I can check back what the methods that I used were. And then we show this kind of file on disk, which might not be the smartest thing to do, but it's actually helpful for debugging. Because we use external URLs, the first thing that the Versus service does is it downloads them in a temporary folder, right? And so these are the kind of path on this. So you can actually go there and look at them. This is especially useful if something goes wrong, then you can go and make sure that at least the input files are there on disk. Anyways, okay, so we just submitted our first comparison. Okay. One day did. All right. So if you try comparing the same file, or whatever file you have, you're going to see that you're going to get a 1, because they are the same. And then copy and paste. Now again, we're all doing this manually, but the point here is that you write code, right? All the clients I'm telling you about, some of the clients, maybe if I show the IDG client, I mean, they're all doing this, right? And RESTful web service, they're all doing code. So we can see that now because I compare the same one, they're actually based on the MD5 that become the same. Okay, so now this is kind of boring because it's 0 and 1. Very exciting. Yes.
Constantine, first question.
Yes. The not final resource. Yeah, this is the minor bug in the HTML that I was mentioning. If I click on it and I go to it, you can see there's 2 V1s. All you really have to do is when you go to the main page right now, don't put in a trailing slash. Leave it out. And then when you click on it, it actually has the correct URL. If, on the other hand, you have this, and you click on it, then you put 2 V1s in it. Again, it's a minor bug in the HTML for this page. The links here are broken. If you come from this instead of this. Yes. It's the same link. You actually download them separate.
I got the same link.
Right. Yes. Yes. Yeah. This particular implementation of the file service does it. Yes. So the IDs that because we're submitting comparisons of the same file, the same URLs, then when they're downloaded, they get the same ID on disk. Therefore, the comparisons happens on the same file, but that's because they came from the same URL. This is an implementation of copying the file over and storing it on disk. I'm not going to talk too much about the implementation of the backend. I have a slide that mentions it, but if you want, you can also store this information somewhere else. So, you can implement it so it gets stored in instead of disk in, I don't know, Hadoop, like some database, wherever you want to put it, Amazon S3, and so on. Okay. All right, so let's do something a little more interesting. The next one uses a buffer image adapter, a pixel histogram extractor, and a histogram distance measure on the same images. As you can see, it's a number. These numbers, like I've said at the beginning, are specific to the metric. So you have to go and look at the metric to understand the meaning of it. There's some function on metrics that allow you to ask things like, what's the minimum, what's the maximum? So you can put this number in context. Some measures implement this, some measures not. So now let's say you wanted to use this for our face detection, right? One way of doing that would be that you always use as data set 1, a picture of a person, myself, and then data set 2 is 1 picture of a person you have inside a collection. You submit n number of these, you get all these numbers back, and then you pick the one that are the most relevant. Okay? Simple as that. Any? Yeah. For that particular use case, yes. You might want to try, depending on the measure, you might be able to interpret more sure about that number. That number might be, might be more meaningful. So you might have a range, or you might know that, depending on where it is on that range, it might be a different thing. These are just numbers, and they're very specific to the measure. So it really depends on the measure. It's hard to have a general on that. Most of the times for distances, as long as these represent proximity, right, the closest, depending on the measure, the smallest they are, or the closest they are to the max, and or they're different, or so for the most part, that's the case. Okay. Any other questions so far? Okay. Okay. So, let me think about this real quick. Yeah. Let's do an indexing example real quick. So, go back to the slides. This is what we did right now. We did a pairwise comparison. We specified adapters, extractors, and measures. We provided two digital objects. We got back a proximity. Now this is what we're going to do. We're going to take files, digital object, and we're going to add them to an index. And then we're going to take a new file, and we're going to query the index. Okay?
We're gonna go to the first opera.
Yes. Yeah. In fact, there's a step before all of it, which is the definition of an index, right? While in the other case, we kind of define it as submission, meaning we define what adapter, extractor, measure we're using when we submit. In the case of the index, it needs to be persistent, right? So every time we index, right, it needs to be persistent. We need to have an ID for it and a specification for it, right? Because it goes over many requests. So the first thing that we do is we create an index. So again, we do a post, form URL encoded. These are the fields that we're posting this time. We specify an adapter. Again, this is a buffered image adapter. This is the same adapter we used in the pairwise, right? We specify an extractor, which I think there's a typo here, which I'm going to fix. One break. We specify a measure. Again, these are the same thing that we're specifying for comparison. And we specify a new thing, which is the way we are going to store the index, the way the index is going to be stored. In this particular case, it's going to be a linear index. Which might sound like you don't really gain much because it's a linear index, but really the advantage here is that you don't have to extract that feature every time. It actually stores that feature inside the index. But it still goes one by one across all of them when we do the query. Okay? So, let's see this break. I think I have a typo here. Or maybe not. Double check. Put in index. Oh, the index actually went in, just different error. Say that again? Yeah. Yeah, just copy and paste. Or you can use the same ID. So we could all use this ID, although I'm not sure I want to ask you to. character by character, unless you really want to. No, but we could share the index, right? We could add to the index, to the same index. If you run yours and you get that ID back, you get your own individual index. Yeah, I don't know what that is. Get back to it. I'll take a look later. It's probably. Oh, sorry, I'm going on local. I think I just I don't have one of the paths specified properly on this. No, it works. No, this is. I think this is the same problem. If you have the slash here and you go index, it gives you an error. But that's if you have two v1s. V1 Ashwini. What do you have? It works. Okay. All right. So okay. So here's a bunch of indices. You can go in. You can look at their configuration. And you can also look that some of them already have files that have been indexed with it. Depending on the index, you have to submit a bunch of files before it actually builds the index. You only have one file. And right now, the minimum is 3 for most of them. Correct? Okay. So submit a bunch of them. So the next line shows you how to submit one. Where are we at? There we go. Okay. Again, you do not have to use this particular file. You can use any file on the internet. For example, a Google Doodle. Sure. Some of these are images. Okay. Yes. Okay. The factor. Here, right? And keep the adapter. Yeah. There. That's the one you submitted. And that's probably because of it. Thank you. Yeah, it looked like there was a typo. So what I'm going to do is I'm going to use vrest to actually properly read it and fix the typo. Okay. So this copy and paste somewhere where you can actually read what it says. So here. And actually help. And the typo is right. I have the wrong. Okay. Extractor. The word says extractor equals. And then this is RGB's program extractor. Package name. Implementation. Although. Here. And if you're confused in what this should be, you can always go to the service and take a look at it. So if you go to extractors, we're interested in the RGB's program extractor, so you can see this is your ID. So you can just copy and paste. Like extract. Take this one. We'll go back to the command line. And double check. All right, that looks a little better, yes? Okay. I'll fix it on the tutorial, and you can go back to it. Oh, you want to do it now? I can. But if you look, the only real big change is you want to fix extractor equals this. This was actually planned, but you actually have, I think, it's all part of the tutorial. Copy and paste. You're not going to learn anything. Copy and paste. Yeah, some sweat. Okay. So once you have an index, let's try it. Maybe I made a typo in there as well. Okay. Are you using the correct ID here? Okay. Okay. So make sure that it's one of the ones that's not broken. So if you look at your indices, sorry, this is on localhost. So if you go and look at one of your indices, you just pick a random one, and there's a null that's broken. So this should have never gone through. It should have complained. So the latest one that you did, ideally, doesn't have a null. Okay, so make sure that you have index slash this should be your ID of the index you want to use. So in my case, I'm going to use this. And where posting is basically just a file. We don't have to specify anything this time about the method used. We're just saying, here's a file, right? And it's going to use what we define when we define the index, right? That index is done. So yes. Yeah. So here, I'll find you one that doesn't have it. After I... So this is the file that I just added. It's listed down below here. So you could use this one if you want. The one that ends in 76A7 and starts in 54D4. So 54D4. 55. Yeah. So you could use that one if you like. The one that starts in 54D5. That one does not have a null. Okay. I'm going to index this dual doodle. As I can. Here's the Google. And like I said, you need at least 3 before it actually builds the index. another Google Doodle. Okay. All right, and somebody else added some DC tank up or something, a tropical fish. Detroit. Okay, so now we have some files in this particular index. What we're going to do is we are going to query. And we're going to query by posting to the query endpoint. What we post is, again, just another file. I go back here, I do my magic ID. And here's the list of proximities, because this is kind of hard to read. I might do it, well, of time, you can see that basically what you get is a proximity value, a doc ID. So it goes through, and for each one of them, it gives you this proximity. As you can see, because my query was about a file that was already in the index, that's the 0, 0. That's the closest. Well, because it's the same file, and the measure itself and the way the index is built makes it such that 0 represents the same. And then for the other ones, you can see a different value. You want to try to understand these numbers, what they mean. You always have to go back to what the measure is, the feature descriptor. It's very, it's one kind of the big questions that I personally struggle from the beginning, is how to make these numbers somewhat meaningful across different measures. But I don't know if there is an answer. So. Test, yeah, that too. Yes, so the more data you have, the more you get a good sense of what the numbers, right, the good distribution. And this Michael brings up a good point, and that is that we did a bunch of decision support on top of this at some point, where we're trying to say, can we try to look at the distributions of the numbers in large collections to help you understand what these numbers are. We're not going to talk too much about that today, but it's work that we have done for yeah, a catalog. Yeah. 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 Yeah, definitely. So Michael is just saying that because it would be helpful to have a catalog that was organized with things categorized by, for example, difficulty or complexity, or have some information about something that we currently don't have. You have to go and look at the code right now to get that all that information. Yes.
You don't need.
In this case, it means they're the same. The closest you are to 0, because of this measure, the closest that you are.
Something to 0.
Yes. This particular one, yeah.
Are there another one?
Yeah, it depends on the measure. I'll show you, they have methods on it that we don't show here. They have number, well, yes, it depends on the measure. I'll leave it at that. Okay, so it's an hour. We should probably take a quick 5-minute break. Yeah. Okay, so if you go ahead and start the download of the service, I'm going to go back to the slides. I'm going to go over to the slides, the rest of the remaining slides, and then we'll go back to hands-on. Before I do that, I can show you, since there was a request, and I know it's getting late over there, meaning in Cyprus. So here is a local version of Medici 2 running on my desktop. And you go to the admin and log in. You can see that we have the ability from Medi of creating indices the same way we did from the command line by specifying an adapter, an extractor, a measure, and an indexer. This list comes from querying the service. So Medici here is querying the service, getting the list, building the pull down. You can select some mix of these. It doesn't right now tell you which one is compatible with which, so you have to know ahead of time. You have to look at the definition of each one of them. Eventually, we'll make it so that it actually helps you through that selection, which we have done in other web apps. So we know how to do that. So in this particular case, here I have one index, and I'm using this extractor, this measure, and this indexer. And so what happens is that every time you upload a file, the file is uploaded, and that file gets also submitted to the Versus that is specified in the configuration file to every single index, and it gets indexed inside that specific index. And even though it's not in the menu, because we're kind of trying to harden it, there is a multimedia search endpoint, which is under files. It has ways to provide that query to search the index. I'm going to pick a file. I'm going to submit it. And what it's going to do is what we showed on that diagram. I'm going to do the second row. It's going to extract the feature, run it against the index, right? All done in Versus. So I pick some random one. Well, whatever. I ask it to search. And so it's uploading this file to Versus. Versus is searching, and I broke it. Hold on. I was playing around with it last night. Oh, that's fine. Okay. All right, let's try that again. No, that's because I was editing the file. When did you see? Where did you see it was still uploading? Okay, well, I'll have to look at it. I'll look at it in a second. But anyways, actually, let me look at it real quick. Okay, 1 second. So all I'm doing is I'm checking the thumbnail extractor. Because there was an error there. Let me try one more time. Yeah, I have an error here. I have to fix it. Sorry. Ooh. Yeah. Anyways, it returns back a list of all the closest one. It just shows you the icons, the distance, the thumbnail, the distance. But for some reason, it's not creating the thumbnail properly, and that's where it's complaining. I can't show it on the page. In fact, if I the following, sorry, wow. So the thumbnails are broken, but as you can see, it identified this particular file as having distance 0 because it's really the same file that I uploaded earlier on and all these other ones with the distances. So I just wanted to show it to show that we have the plumbing in to actually do this for Medici and use Versus as a way of doing queries. And then on each one of them, you can ask it to find similar, and it will use that particular file as the query for all the files that have been indexed so far. Okay, all this code is in the master, with exception. I have to figure out the thumbnail is basically, if there is no thumbnail, a complaint, but I'm going to fix that this afternoon. Okay, so I'm going to quickly switch to the slides, unless there are questions.
Not 0.
That's, as soon as the thumbnail works, that's the no visual one, because you can actually see at the image and you can see the similar ones and the dissimilar ones. Yeah. So that's probably right now, probably in terms of indexing visually, the best that we have in terms of actually seeing the files themselves. Yes, I can show those. Yeah. So, yeah, let me do that real quick. Okay, so this is the LSVA work that we did last year. But you can see that this is the top, kind of, you can see how close they are. And I think this one, I forget, unfortunately I wasn't in the screenshot, but I think this is a mix between color and edge detection. And so you can see how it's actually seeing that there is some blob here in the middle. There is this other one. Actually, this is the one. This is the one that this uses instead of color. This is looking at edges. So the colors are completely different, but you can see how it's actually finding tree blob here, right? So you can see that, and if you scroll down, right, it would get farther and farther apart. But this is the kind of thing for images that you can now keep in mind that. I mean, a lot of our focus is on image, but in general, the framework you can also do it for PDFs. And there is a method that we have worked on over time, PDFs, text, and the goal here is to make it easy to build up that library, like we mentioned. Okay. All right, so we'll show how master and slave works in practice if you want to set that up. But really, the big deal here is that what you can do is when you run the service, you can run an instance, and that's it. You're done. Running an instance, you're talking to it. That's all that matters. What you can do is you can run multiple instances, and you can make one the master and all the other ones a slave to the master. Okay. The moment you do that, the master just works as a router, routing jobs, to the node, to the slave, that can fulfill that job. It's actually somewhat smart in the sense that it actually asks the slave for what jobs are available there, okay? Why is that useful? Well, if you have, for example, a machine with a GPU and some special method on it using the GPU, you can put a slave there, right? Then you have a pool of machines that don't have GPU, but they have a bunch of software running on them that you want to use for some method. So what you can do is you can have a bunch of slaves, as many as you want, and each one of them can have different methods. And you just talk to a master, and then the master asks the slaves, and kind of in round-robin fashion finds the first one that can support that method and sends it to that slave. The other reason to do this is scale. If you have a lot of traffic, you're trying to do these kind of comparisons for a lot of files, then obviously you might want to take advantage of a cluster, and so you run the slaves on each node, the cluster, and the master somewhere. And that's it. That very simple master-slave architecture, and we can try setting that up if there's time. I'm going to do that next, but I'm going to skip it, and I'm going to finish. There is not that many more slides. Storage, there's different implementations of the persistence layer, and this is ongoing work. But the idea is that anytime you need to store some information, for example, the index or a previous comparison, so you can go back and look at the result of it, there are different ways to store that. And for now, we're primarily looking and implementing it again. An in-memory one where everything is stored in memory, so if the service goes down, you lose that. But it's helpful for quick kind of situations, testing, and so on. The file system where everything gets serialized to disk once it's done and deserialized from disk. And a relational database, MySQL primarily, although it could be adapted to other relational databases, and MongoDB. I'll show you how you can flip those and pick between them. By default, the service, and this is all in the service, because the core doesn't really worry about how to store things. It's just really the engine and the API. So I'll show you a little bit of this. But adding implementation, you write Java code. In the Java code, you can execute arbitrary code, so code that is not Java, by doing things like running command line using runtime exec from Java, or Java native interface if you're brave enough. So your usual things. So this is primarily a slide about Java. You have to implement it in Java, but really you can implement it in another language, and as long as you register it with tiny Java wrapper, then it's available to the system. And then the third thing that you have to do if you're adding implementations, which is the most important, not the most important, but it's a very important one, is you have to register them using Java services. And again, I'm going to show in the code how this works in a second. But primarily what you're doing is you're saying, for example, let's say you just created this particular RGB histogram extractor, so you wrote some Java code, you put it in a class, and now you want the system to know that this extractor exists, right? So that you can show it on the list when it tries to run it and knows how to find it. Then we use this built-in Java services to do that, and it's as easy as just adding this fully qualified class name to this meta-inf services file. It's one name per row. This meta-inf lives in a jar. If you're familiar with Java, that's how you package Java code. So as long as that jar is on the class path and the meta-inf is on there, it will find it. So that means that you can have methods in different jars, and all you have to do is literally copy and paste that jar over, and it will find it. And I'll show you a demo of that, and you can play with it. Very straightforward. I was going to show how to deploy new methods. I'll do it afterwards. Medici as a client, I kind of showed. And then there's only just one quick mentioning about some future work on the short term. This is not a comprehensive list by any means, but some of the things that we're looking at right now is how to store intermediate data structures to disk. This is actually, I should have specified, this is features. So the original design of the pairwise was that we would create the feature every time we did a comparison, right? So the whole job would be one unit. And over time, we realized that that's kind of overkill because a lot of the use cases use the same files in multiple comparisons. So we want to make it easy to store that feature and not have to compute it every single time. Service reliability. Right now in the master-slave configuration, if a node goes down, or even in the single configuration, if you have jobs that are have not gone through, you will lose them. So there is that. The slave goes down and was working on a job, a master will not ask a new slave to handle that. So all of this is part of reliability, and we're looking at ways in how we can make that robust and reliable. And the third one is to be able to split step across nodes. We haven't, well, as I mentioned, the master-slave, the master gets a job, and then it picks the slave, and it sends it to the slave. But what it sends to the slave is the full flow, right? It's the full, all the steps for a particular comparison. But you can imagine how it would be helpful if actually you could split that up, and maybe one node might be creating the feature descriptor, another node might be calculating a measure between the feature descriptor. So that's another view. And that concludes my slides. I was just going to go back to hands-on activities. So are there any questions about any of this? Yes.
So,
Yeah. So, yeah, thank you. So Michael asks, have we thought about how to specify parameters at runtime? As you saw, when we submit a comparison, we specify the type of the adapter, the extractor, and the measure. But let's say you have a measure that you can tweak, right? So you have parameters. Right now, they have to be embedded inside the implementation of a measure. It would be nice if our runtime you could specify value for these measures. We haven't done it. It's a very good point. We should maybe add it to the list of more short term. I think it should be driven by demand. So if we have a lot of use cases that require that, we can definitely do it. In terms of implementation, it's not hard. Yeah, Richard, the master-slave handles some of the scalability issues. Also, the indexing is another way, depending on your use case. So I hope that answers that. I don't know. Yeah. Okay. All right. Well, then, unless there are any other questions, we'll go back to hands-on. Okay, hands-on it is. Okay. So going back to the page for the tutorial, please download the latest build if you haven't done so already. Unzip it, and let's take a look at what's inside. This is the service. The service wraps the core. I've made a temp directory where I have my zip file. I've unzipped it multiple times, 1, 2, and 3. This is because I'm going to show you some of the master-slave with different implementations. You really don't need to unless you want to reproduce that on your own machine. Really your call. Inside the service, there's a bin directory. Inside the bin directory, there's a startup.sh and a startup.bat. Bat for Windows, sh for everything else. You can ignore slave 1 and client for now. before you actually start this, you want to go to source, main, config, versus.property. These are the properties that you can set to configure the system. Don't pay too much attention in this hierarchy. It will probably go away. I mean, it will be flattened. So this is what a versus.properties look like. If you want, you can specify a master in here. So if you want this particular instance to be a slave, you can specify a master in here. You can also do it from the command line. We'll be doing it from a command line. You can ignore this for now. Then these are all the implementations of the different pieces in terms of storing your results. I would leave them the way they are right now. You can see here the different options available. Down below is probably the most important thing. This file folder, index folder, file map, file directory. These are, because we're using implementations on disks, the folders where the information is going to be stored. For the most part, we're not going to be doing a lot. I mean, yeah, okay. So for the most part, these are important for the indexing, not necessarily for the pairwise comparison. The one that you might need, so the first three are primarily, okay, let me rephrase. This important for indexing, the first folder, index folder, is really only important for Medici, right? For the most part. Yeah. Okay. Maps is commented out. Say that again. Okay, that's fine. Let's take a look. Okay. So replace with disk. Yep, as you can see, either disk or MySQL. And then these folders you have to replace no matter what. So this is some folder on disk where you want to this information. In my case, I store it under data versus. This is just a file. This is a folder. This is a folder. What does it look like? It looks like this. A directory with an indexer directory and an upload directory in it. Yes, you can leave the man. Okay. All right, go ahead and do that. I'm gonna check. Okay. In the meantime, if you would like, if you already have done this, or try to follow along with the code in the tutorial, we have 4 projects that are kind of required to build the service. So if you want, you can just check out. You should go ahead and check out these 4. One is the core. Then there is one of image-related implementations of methods, census-related implementations of methods, and this is the server. So you can do that by doing git clone on the command line or using git. These projects come with an Eclipse project file, so Eclipse should already ask you if you want to import it. If you do it from the command line, you should be able to import an Eclipse right away. If you have the source, I can show you how to build it. So down below, we use Maven. I can show you how to build it, but that's really, if we get time or not. It's actually, in a way, almost based on request. So it's up to you guys. Yes. Yeah, you can just use master for when there is multiple branches. On downloading the zip and unzipping, then it should look a little different. You can just copy and paste that versus.properties that you edited over. That's the only configuration file that you need to tweak. Yes.
Do it by path.
Yeah, the path. And also make sure that that maps the disk. Oh, one more thing. Down here, there's the number of threads. You can set how big this is the thread pool of the engine. So how many concurrent jobs you have. And this Linux Windows is required for the startup and
for the master.
yeah.
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 So when you try to get the IP address, so within Windows and within
The JVM does
Yeah.
two different things. Yeah.
that
We'll probably be able to make this decision in the code, checking which OS you're on. But for now, you have to specify it. If you're using the master-slave configuration. Okay. Anybody having any issues or have any questions? Okay. If the case, if you're all good, if you could please go to the bin directory of the service. I have many windows open. Speed things up. Okay, if you go in the bin directory, you have a startup.sh or a startup.bat if you're Windows. If you run that, it'll just start the service. And it will say, I am the master of the universe. You can see here the URL. It's an IP address if you have. Really, this port 8080 is the default port. So if you go to the browser, and you go to localhost 8080, it will say, oh, I got a directory, because really you want API version 1. And here's what we're familiar with. Click on one of them, and you can see what you have in terms of extractors that are installed. Okay. So, as you can see, if you look at extractors, I have 3 extractors installed. You should have more. Good. The reason is because you have the image method on the class file. So, if you go to the lib directory, here's my lib directory. There's a bunch of jars. The ones that start with versus are the more interesting ones. What I did is I removed versus-image, which has the image method. If you checked out the source code, the versus-image project is the one I'm talking about. If you build that one, you get a jar. You put the jar in here and you start it up, you get these methods. So for example, in my particular case, you can't see any extractors. I mean, you can't see the image extractor. You can see 2 extractors that are in the core and 1 extractors in the census package. Now, if I go back here, I look in here under lib, it might be hard to see. You can see I have a versus image. I copy that jar, drop it in here. I drop it in here. There it is. Till X. Okay. And I go back here. Okay, now, unfortunately, you have to restart the service to pick up the changes. One of the things that we're trying to figure out is how to do this on runtime. There are ways to runtime, so that if you just add the class path like that, for example, it actually will pick it up. We don't do that now. You have to stop the service, start it again, go back here, and now you can see all of that. Okay? All right? Got it? Yes. Yeah. Like on errand thread text 503, problem X, the reason service unavailable. What do the logs say? So if you look at the logs, do you have an error? Does it say my URL? Oh, does he have the actual URL? Yeah, make sure it's 8080. Yeah, look at the logs, because the logs tell you what your IP address is and the port. Make sure, like John said, that the default port is 8080. Are you on Windows or something else? On Mac? Okay. Port. And you have to go to API version 1. Okay. So, okay, if the port is in use, what you can do is use the first parameter. So you say startup sh, and then you provide a port. For example, 8182. Okay. How are we doing? Okay. Anyone else have any questions so far? Everybody up and running? You can see it. You can see the list of methods. You can run the same curl commands against it or any other client. Are we good? What version of Java do you have? And what's the error? Okay. While you figure that out, I'm going to show a couple of things. So, one is the port. The second, so let's say I run, okay, so if you want to see what master and slave kind of works like, you have 2 options. One is we can run many instances of the same versus service. This will mean that all the instances we have will have the same method. If you want to look at how master and slave works with slaves that have different methods, then you have to copy the directory, so the entire kind of versus service over, so that you can remove some jar, right, in some. and not another. Okay, so that's what I did. I made multiple copies, and some have some jars, some have some don't. So I go into my first copy and I run the service on port 8182. It starts up on port 8182. I can go to it. Now I go in my second folder. And then I run the service on port 8183. I also provide a third argument. This third argument is the fully qualified URL of the master. In this case, I'm on port 8183, API version 1. When I execute, I get that I'm a slave. I get that my URL is 8183 and that the master URL is 8182. If I go to the browser or using curl, yes. Yeah. Again, that's up to you. Also, the slaves, in this case, we're running on different ports on the same machine for the sake of testing, but each one of the slaves could be on a separate machine, right? There's, you know,
And you get the folder to start from. You know.
So now if you go to the browser and you test, you can see that, oh, 8183 is also live, okay? So now I have a master and a slave, okay? Now I go to my third directory and I run on port 8184 and I connect to my master on 8182. The slave, I go to port 8184 and I see that in this third instance, I actually have more methods, okay? Now, if I go back to 8182, which is my master, and I go to slave, I can actually see what the slaves are. And if I follow it, I can go exactly to that slave. So, what happens is that from now on, when we talk to the master will query the slave, and it will see who can. So if we do a curl submission of a comparison to the master, we'll go around and we'll say, okay, who has these methods? Okay, you have these methods, you did the job, right? Yeah. Yeah, it starts asking in a round robin fashion, and the first time it finds one. Yeah. We're using the same program. Sorry. Oh yeah. I forget which one overwrites the other. I don't remember. We can look at the code.
But in fact, all of these are
the service calls the rest. The services talk to each other. The shell script just runs. So let me. That's important because this is actually useful once you start. No. So if you have checked out the code and you go down to versus service and you look at service, this Jetty server class is the class that gets executed from the shell script. If you look in the shell script, it's just running this class. And so let's see, master properties get master. So the command line overwrites the property. Okay. So now if you want, you can do curl. I'm not going to do it for the sake of time, but you can hit the master and you will see the slave having the job. Or maybe you'll make it if you believe, south. And then see what happened. Did Chun-Li, were you able to get it up and running?
Yeah, got it figured out. Yeah.
Oh, no problem. Okay, good. So it didn't work for you with 1.6? Because it should.
Be downloaded.
Oh, I'm sorry. Yes, sorry about that. Sorry. Yes. Thank you, Chris. Yep. Sorry about that confusion. Okay. Good. Okay. So that's master slave. Let me see. Deploying new method. Let's talk about that. Okay. All right. So if you have all the source checked out, you should. Sorry, this is kind of small, but I don't know if there's a way to blow it up. Nope. Okay. Sorry. But if you pull it up on your machine, so ideally you have the code checked out. Okay. So how do you create new implementation and you register them with the system? Open up versus image. This versus image project has none, so it depends on the core. So the primary thing, so versus image is a good example. So if you wanted to create your own project with your own implementation for your methods, versus image would be a good example to follow. Really, you don't have to do it this way. You don't have to use Maven. All that really matters is that, one, you're building a jar, right, at the end of the day, or right, you have to package your files. Inside that jar, the most important thing besides the classes themselves is, if you go to MetaInf, under main resources, MetaInf services, is that you register your classes this way. These are the fully qualified names of the interfaces that you have to implement to create a new adapter, extractor, feature, or measure. For example, if we go to versus image and we open up adapter and we open up buffered image adapter, we can see that it implements and as pixel. As pixels, extends a bunch of classes, eventually they extend adapter, right? This is the Java API we're talking about at the beginning, okay? Most of the methods here are very simple, right? The interface is a few methods. It's not very complicated, some more than others. But the idea is, if your implementation implement this interface, and then you go to MetaInf services, you added the fully qualified class name to one of these. Then you take the jar with this MetaInf and the class, you deploy it on the class path, based on the lib directory, then it will appear, right? We'll know of it. If you want, and you want to build the system from scratch, and you have all four, the first thing you want to do is build the core. Oh, I forgot. Because in the implementation, the only other piece that you need, so for example, versus image, the only main piece is that you have a dependency on a jar for the versus core, right? Otherwise, it will not know where adapter is. If you look in versus core, let's take a quick look. You go to versus core, source main Java. There will be a bunch of folders. This is where the definition of an adapter lives, versus adapter. This is where the definition of a descriptor, a feature, a signature lives, right? So you obviously need to have these interfaces in your own project when you're implementing this method. Otherwise, you're going to know what to do with that, right? But that's really the only jar that you need. All the other jar, for the most part, well, you need a few more jars if you, depending on how you want to build it. So if you want to make your life easier, what you can do is use Maven. And then if you look at the image one, which is broken. I plug it broken. Um, in the pom.xml, you can see the dependency. And really, the main one is this versus core, commons logging. It's minor. This I am to learn, Jaya codec, and Jaya core are specific jars for the image method. Okay? So it's true, I misspoke. When you want to use the versus image method, you actually have to copy all the jars that also the versus image depends on. The easiest way to know what they are is to use Maven. And maybe, so initially, maybe build it. So how do we build? We have done this before. I'm not going to spend too much time on it. But if you if you go to the tutorial, it's in the tutorial. At the bottom, it basically says, if you do an install, it will create the jar the same way it would if you do a Maven package, and it will put it in your repository. So now in your other project, it will find a jar if it's shown as a dependency, right? So I'm not going to spend too much time on it. Just try it if you're interested in. This is straight Maven. There's no magic here whatsoever. The only thing that you have to keep in mind is that in the case of the service, you have to run this assembly target. That's the one that creates the zip file with all the vars, because the service is the only one that requires you, right, to run standalone. Everything else is just jar, right, that you use in your client. Okay. Any questions? You're going to try to build it? You want me to go through the code? Are there any requests? Since it's 11:15. No requests? Okay. Okay. So I'm building it as simple as doing Maven install. Do it in the core, image, and census first. Then do run a Maven assembly on the server. And you should have everything you need. If you don't, you have problems, you can ask afterward. Send us an email. Okay. So then briefly, I'll touch upon some of the API, just to give you a sense. I'll just browse classes, and I won't spend too much time on it, but because this is pretty advanced, it's only if you want to write new methods. But that's part of really the reason why we're here, is because we want everybody to contribute new methods to this framework. So if you open up the core, that's where the core API is. If you open up adapter is the main interface. It has a get name and supported media types. This is basically the MIME type that it knows how to do something with, right? So, for instance, if you open up adapter implementation, there's a bytes adapter. Bytes adapter takes in anything. If we go to versus image, Java buffered image adapter, which uses the Java libraries to open up images, and we look at support media type, again, we claim that we can do anything that starts with image in terms of MIME type. Adapter is one of the few interfaces that has a bunch of implementation. And this is where we start going into the realm of different data types. Most of the ones over here in the core are pixel-based for images, but you can see that there is an as text and as vertex. So if you have text, you're expected to return a list of strings. If you have vertices, you're expected to return a list of double arrays as vertices. You also have a get vertex, get a specific vertex. As long as you are extending adapter interface, you're good. you shouldn't have a lot of interfaces like this, because the goal is that when you go and write an extractor, you're using an interface that's already in the system, right? So that people can reuse what the adapter that was created for you by someone else, right? So the idea here is that most of the time you want to try and see if there is already something existent, don't create a new one. So for example, let's take a look at an extractor. Go to versus extract. The extractor interface is a little longer. There's a couple of deprecated methods that we're getting rid of. In the extractor interface, the main kind of method is extract. It takes in an adapter, returns a descriptor. There is also methods for getting metadata, such as getName, supported adapter, right? So what adapters do I support? I know how to deal with. What feature type I spit out. So for example, MD5 extract, very simple. For the adapters, has bytes. That's it. That's what it supports. What does it output? MD5 digest. Okay? That's it. What is an MD5 digest? The feature, right? Remember the diagram? So it's a feature. What's a feature? It actually, a feature is a descriptor, and the reason I'll explain to you why there's the direction. A descriptor, again, very generic, very simple. These are called marker interfaces for the most part. Well, not this one, but the bottom line is really they're primarily a way to make sure that you can register them, that you can find them, right? In this particular case, there is a little more information. But descriptors we divide in features and signatures, and the only reason is that we wanted to represent individual features and collection of features, and we call that a signature right now. So we're looking at the MD5 digest feature. In this particular case, it's just the raw byte as an array of bytes, right? It has a name, pretty name. It has a type, which is just the type of the class. And if we want, we can get the diagram. So this all goes back to that diagram. All we're doing is looking at this adapter, this extractor, feature definitions, measures, a measure has a compare method. It takes in two descriptors. It returns a similarity. Again, you can ask it, what kind of feature types does it support? This one spits out a similarity, which is the last box in our picture. Similarity is a marker, a proximity. Proximity is the last number that we see when we run things, right? That's all it is. As you can see, there's a get value, which is what the service show you that number. There's also get min value, get equality value, get max value. Again, it's up to the developer to actually implement this and make them meaningful. Some of these, some of our implementations are not even implemented. So this is something that kind of flux. There's always also an attempt to try to create specific ones, things like similarity percentage, which that way you know it's a percentage, you know more about it than if it's just a number. Some of this just, we're just trying things. inside the core, briefly, if you're interested in looking at, there is the registry, which is the one that uses those meta-inf services to actually load and know what's available on the class path. And there is a engine, which is what we use internally to execute, to submit job, right? Where a job is what you saw when you submitted to the service, two data sets or files, and then an adapter, an extractor, and a measure. That's all it is. Last thing, not least, this is what the interface for an indexer is. You can add descriptors. Remember, every time a file comes in, a descriptor is created, you add it to the index. You can build it. So in case it's expensive to build index, you can actually add descriptors, and then every so often say, okay, now build, right? So you don't do it every time. And you can query. You pass in a descriptor, you get back some search result. Search results have a proximity you're familiar with in the pairwise comparison case, and have some internal ID, because the index needs to store some internal ID to identify the document. Okay? And I'm going to stop there because I think everybody's probably tired, and this is usually the most boring part. Unless there are questions for me. Otherwise, this is something that we can talk offline, especially if you want to start implementing method. Please let us know, and we can kind of help you through the process. And that's all I had. Question? Yeah. Yes. A wonderful question. So when we started, we had none of this. And it took a while to come up with how we wanted to model this domain. It took a long time. We had many conversations. Most of this representation primarily comes from computer vision and machine learning. So if you're familiar with that, then you're familiar with the setup, really, like feature descriptors and extractors, right? Those are part of these disciplines, and we adopted them by looking at literature and finding what was the most common and intuitive way. Then we added measure as something that, right, is something that made sense for the pairwise case. And when we got to indexers, it's just an index. So again, it's a very simple model of yeah. Adapter comes from a design pattern. That term comes from a software engineering design pattern, where you're trying to get access to data structure, but you don't know how to, and so you need an adapter to do that. That's where adapter comes from. Yeah. Yeah, that's, yes. So if you go to registry, sorry, do you have a lookup? Michael is asking, do you have a lookup table to know what fits what? So given an extractor, what adapters can it support, and so on. That code is not in the core, and is, wait, let me see. There was something in the core, so I'm looking up the class. So compare registry had something like that, where there was a feature extractor map, for example. I think what we started doing is moving this to specific implementations. So what we do is, in a client, we'll say, what are all the available adapters, what are all the available extractors, and then we'll just basically match. So it's something that the code moved to the web app in the client. I don't believe it's in here. I'm pretty sure it's not in here. But we should move it to the compare registry, because all the information is here. I don't know if this, I don't remember when it was deprecated. this might still run, but what I'm saying is that we developed that in the client. So we have to either port it back or rebuild it in here. It's trivial. I don't remember why we stopped doing it in here. Yeah, but we also have the code in the web. Are you doing that in the new web app? Old web app, remember, you could pick an adapter and it would highlight all the extractors that are compatible with it, and then hide all the other ones. Remember that? Yeah. So that code was in that web app. That web app is not maintained anymore, but it's simple code to write. So we should do it. This is a really good question. It should go back in here because it's something that all the clients need to be able to do. So that's a very good point. Yeah, thank you. Okay, well, yes. We're keeping the API fairly stable so far, but there are times where we make changes. So for example, the indexer were added a year and a half ago, 2 years ago. Moody made some modifications to it maybe a year ago. Inna made some changes to the engine interface. So there are some things. The core APIs haven't changed in a while. So at this point, especially since we have multiple people kind of working with it, I think at this point, we can start maybe calling it a 1.0, and then any modifications on top of that, call it a 1.1. It's just hard because the moment you do that, then you change things under people kill you. And they come with pitchforks, stand outside the door, and can't go out. So I don't know. I'm scared. The which one? Yeah. Well, that's a very good point. That's another thing. So there's two APIs. One is the Java API, right, that we just looked at, and the other one is the service API. So two reasons for people to come with pitchfork attack us. So even internally, what I mean. So there are two. Yeah, exactly. good idea. So yeah, so there's two of them. There's two. There's the service and there's the core, and we should keep them separate. So we should just make sure that if we make changes, they're backward compatible. Yeah, but really the other thing to keep in mind here is, to a certain extent, you need a version, but at the same time, as long as it doesn't change under you, where there's a live service that people are using and it randomly changes, if you're in control of the service, you can always make sure that you have the version that's a mix. She rewrote that from what I had. No, that's in the service. Yeah. Yeah, that's not really the API. That really, yeah, but that's a good point. If the slave's endpoint changed, that would be. If you had versions of the service run, yeah, so, yeah, in a way, we want to make sure that if we put, we added version 1 there to remind us that we're working towards a version 1, and also people start writing clients against it, it's not going to change. But, yeah. Once we say this is version 1, then you're going to be very careful about making changes. And the only way we can get there is by people using it and yeah, testing it exhaustively and also giving feedback. So, the more people we have actually using it and having to go through the pain of writing code against it, the closer we'll get to that version 1, right? If it's just few of us doing it, then we know all the quirks, so we work around it, but we never get to the maturity, right? because we know the quirks and we got to get the work done.
There's a question. Yeah.
Okay. One question: if you get features about features, why does it return descriptors and not features? That is probably a bug. Because at some point we made the distinction between descriptors and features, and most of the time, if you get features about features, why does it return? Yeah, so it's not a bug. It's we used to just talk about features, and then we decided to make the distinctions between features and descriptors. So, yeah, so the method name should change to reflect that if you look at descriptors, the API has a descriptor, and then there's a feature and a signature. Yes, thank you. So the generic name should be, yes, get descriptor, because that's the topmost. Very good point. So here's an example. So, right, we got to change this. The moment we change this, all the implementation needs to change to have now, instead of a method call. So if I go to extract, extractor, right, feature type, right, it actually returns a descriptor. The moment we change this to get descriptor type, then all of a sudden, all the implementation need to change or reflect. So, yeah, thank you, Konstantinos, for bringing it up. And this is a very good example of why, you got to be careful, because it's a lot of work now to go through and change everything. And if we own it, it's easy. But if somebody else owns it, that's kind of annoying. But anyway. But that's in general something about APIs. That's what have to learn in mind when you build them. All right. Thank you, everyone.